After studying the limit definition of derivative, which is a tedious method to find derivative, allow me to introduce you some shortcut to find derivative. And starting from now on, we will be using this shortcut to find derivative. So speaking of derivative, what is derivative? So when you hear the word derivative, that means we are finding the slope of a function at any x value. So derivative means slope. So if you see one function only, and I'm asking you to find the derivative of that function, that means I am asking you to find the slope. What if you have see the word derivative in application problem? So in application problem, derivative means rate of change, which means how things change with respect to a variable. So which is rate of change. So let's move on to the first rule. The first rule is a constant rule. So do you see that there is a d dxc equals to 0? The d dx means, so the d in the numerator means derivative. d dx, so if you take this as one whole thing, that means the derivative of constant c with respect to x is equals to 0. That means the slope of a horizontal line is equals to 0. So let's say you have a horizontal line, so let's say y equals to 6. So what is the derivative? The derivative is d dx of 6 is equals to 0. Y equals to 6 is a horizontal line. The slope of a horizontal line is equals to 0. What if you have f of x equals to negative 10? Then f prime of x that is equals to 0. Y equals to negative 10 is a horizontal line. The slope is equals to 0. That is called the constant rule. So the derivative of a constant value is equals to 0 because the slope of a horizontal line is equals to 0. And then the next rule, the simple power rule, you will be using this a lot, simple power rule. So the derivative of x to the nth power with respect to x is equals to n times x raised to the n minus 1. So the first step that you will have to do is you bring the n down to the front. So you bring the power down and then take the power minus 1. Again, you bring the power down and then take the power minus 1. So let's do a few examples. So let's say we have f of x equals to, let's say x to the 5th. So f prime of x is equals to, you bring the phi down, and then x raised to the phi minus 1. So with a little bit of practice, that is equals to phi x to the 4. You can just do this in one step. Let's do one more. So let's say we have g of x equals to x to the 10. So g prime of x, that is equals to, you bring the 10 down and then x raised to the 10 minus 1, which is 10 times x raised to the 9th power. So with a little bit of practice, people don't write the minus 1 anymore. People will just do this in one step. But since I assume this is your first time doing this, so I will have to show the entire step. Okay, you might ask me, hey, how about fraction? So let's say, let's switch to another color. So let's say we have f of x equals to x to 1/2. So what about f prime? So f prime of x, another way to think about this is the derivative of x to the 1/2 with respect to x. Okay, the derivative of x to the 1/2 with respect to x. With respect means you treat x as an independent variable. So you bring the 1/2 down and then x to the 1/2 minus 1. So 1/2 minus 1 is negative 1/2. So that is 1/2 raised to the x to the negative 1/2. One more. Let's say g of x is equals to, let's have a number, x to the 2/5. So g prime of x, that is equals to, you bring the 2/5 down and then x raised to the 2/5 minus 1, that is equals to 2/5 x raised to the negative 3/5. How about negative exponent? So let's switch to another color. How about f of x equals to x to the negative 4? So if you want to do the d dx, that's fine. So the derivative of x to the negative 4 with respect to x, you bring the negative 4 down, x raised to the negative 4 minus 1. So that is negative 4, x raised to the negative 5. So try another one, g of x, let's say x to the negative a. So d dx, or x to the negative a, that is the same thing as g prime of x. So this is you bring the negative a down, and then x raised to the negative 8 minus 1. So negative 8, x raised to the negative 9. How about negative fraction? All right, switch to another color. So how about negative fraction? So let's say f of x is equals to x to the negative 1 over 4. So f prime of x, you bring the negative 1 over 4 down, and then take the negative 1 over 4 minus 1. So that is negative 1 over 4, x to the negative 5 over 4, right? Negative 5 over 4. Let's try one more. So let's say g of x, that is equals to, how about negative 1/3? So g prime of x, you bring the negative 1/3 down, and then x raised to the negative 1/3 minus 1. So you have negative 1/3 x to the negative 4 over 3. Okay, so let me introduce you one more rule. So if you can do the simple power rule, you can do the next one very easily. So the next rule that I would like to introduce is that is called the constant multiple rule. So constant multiple rule. So the constant multiple rule is you are taking the derivative with respect to x. The function is you have a constant times a function. So that means you can just take the derivative of the function and then leave the constant in front of it. So let's say we have f of x equals to, let's say, 5x to the 20th power. So what is the derivative? The derivative is you leave the 5 over there. You bring the 20 down, and then x raised to the 20 minus 1. So this is 100, right? And then x raised to the 19th power. How about negative? So let's say g of x is equals to 3, x raised to the 100th power. How about negative 3, negative 100? So g prime of x, that is negative 3, bring the negative 100 down, and then take the negative 100 minus 1, so you get a negative 101, right? So that is g prime of x equals to positive 300, and then x raised to the negative 101. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you are on your way out. I appreciate for your help. I will catch you all in the next lesson. Signing out.